Okay, what we're going to discuss today is what's known as the allowing problem. An allowing problem is where you have your vessel steering a set course and speed, and there is leeway and also current, both or singly, affecting the vessel. And you're not going to attempt to counteract what's happening to you. It's simply happening, the leeway and the current, and it's going to affect the vessel's position on the chart. So let's have a look at what we call an allowing problem. The information we're given here is that we have a position at 10 o'clock, which is just here, and we're steering 280 true at 15 knots, with a southerly wind causing 10 degrees leeway, with a current setting 050 at 3 knots. And it tells us that we want to calculate the following at 11 o'clock, so that's an hour's steaming time, the DR position, SP position, EP position, and also the course and speed we feel we've made good after being affected by leeway and current. Okay, well, before we start, first, one very important point to note: in a problem like this, you always allow the leeway first. So it's leeway first, current second, always in that order. When we do the plotting now, we're going to actually plot all three positions, DR, SP and EP. The DR position is simply a position that you would reach without being affected by leeway or current. You wouldn't normally plot this in a question like this, but I'm doing so today just to differentiate between the positions for you. So let's start. 10 o'clock position here, vessel steering 280 at 15 knots. So let's run a course of 280. So the course of 280, and this is for 15 knots. 15 knots, so let's plot that on our chart here. Now on a chart you would mark your DR position simply with a single line, as so. One arrow, and this is our DR or dead reckoning position at 1100 hours. So what we're saying is, had there been no leeway, no current, the vessel would have steamed along here at 280, and that's where we felt we would be at 11 o'clock, our DR or dead reckoning position. But what's happening is there is a southerly wind causing 10 degrees leeway. Now you always think of the wind as coming from what you're told. So this wind is coming from the south. If it's a southerly wind, it's coming from the south. So if it's coming from the south, that means that if we have the rubber here, it's pushing us that way, because as we can see, the compass rose, that's north there and south. So the wind, 10 degrees worth, is pushing us that way. So if we're to look at our compass rose and put our rubber there, and we're steering 280, then if the wind is pushing us that way, then our water track, our track through the water, after being subjected to the leeway, is going to be 280 plus the 10 degrees, which is 290. So let's plot our water track. Okay, so that's 290 at 15 knots. Right along a bit further. So that has a single arrow, and that's known as our SP or C position at 1100 hours. It's worth noting at this point that when you run this course, having allowed the leeway, you don't need to make any allowance against the speed. The speed is still 15 knots. for Chartwork plotting, examination purposes, you simply run the speed that you're given. You don't have to start worrying about how the leeway has affected the speed. So that's known as our C position. And this course is known as our water track. So that is the water track. Now, in the steaming for an hour, it tells us that there's a current setting as 050 at 3 knots. So let's plot the current, and we always plot the current from the C position. So 050 there, 3 knots. Let's get 3 knots from the C position. Now, the current always has 3 arrows, as I've indicated there. And after allowing for the time, you mark the position with a triangle. It is always a triangle, and this is known as the EP, or estimated position at 1100 hours. So that is the EP, or estimated position. When you're dealing with current, when it tells you a direction, which was 050 in this case, then the current is going in that direction, and the arrows indicate that. So as you can see, I've put the arrows that way to indicate that the current is 050, and if we take that to the compass rose here, you can see it's pointing in the direction of 050. And we've allowed it for an hour, because when you're given the current, you're always given it that the time distance that you're given, 050 by 3 knots, that 3 knots is for an hour's time. So we've steamed for an hour, so we plotted it for 1 hour. So we've had our DR position, with the helmsman just steering the 280. We've allowed 10 degrees southerly leeway, and now we've allowed our current. So if we wish to get our course and speed that we've made good, then we simply join from our 10 o'clock position to our estimated position. So we run from 10 o'clock to our estimated position, and we can look on the compass rose and see that the course that we're making good is actually 300 degrees true. We indicate this course and speed made good with 2 arrows, and as you can see, we've completed what's known as the vector triangle. And in the vector triangle, the water track has 1 arrow, the current has 3 arrows, and the course and speed that you make good has 2 arrows. So I'll write that on here, course and speed made good. So that, in an hour steaming, that's what we've done. The course of 300. Let's just have a look at that in practical terms when you're thinking of yourself on the ship. The helmsman is pointing in this direction at 280. Now, had nothing been affecting us at all, we would simply have followed this track for an hour to arrive at this DR position. Had there just been leeway, the vessel would still be pointing in that direction, the helmsman would still be steering that course, but you'd actually be coming along the water track, like so. The vessel's head would be pointing in the direction of 280, but you'd be coming along this track here. With both the leeway and the current affecting us, the vessel is still pointing, the helmsman's still steering 280, but we're actually now going along this top course here, the course and speed made good. So we're going along this line, but the head is pointing towards 280 until we reach our estimated position. Now, let's see what speed we think we've made good. And the speed will be the distance from the estimated position to our 10 o'clock position. And if we check it against the chart, 13.6 knots. So we're actually only steaming at a speed of 13.6 knots. We felt we were doing 15 knots, We're doing 13.6 because this current is actually pushing slightly against us as we're steaming along. So the current's coming in this direction, slightly going against us, so we've only done 13.6 knots in an hour. And our course is 300 degrees because of the effect of the current and the leeway. So that's what's called an allowing problem, where we've simply allowed the leeway and the current to affect what the vessel is doing. And that's all the information there that you can see. Water track, course and speed made good, the current. When you do these problems, you wouldn't normally plot the DR position. I've simply done that to show you the difference. What you would do, you would write your course on your answer script as so, 280 true, and you'd write leeway 10 degrees, and then you'd write water track, in our case 290 degrees. So you'd write that on your answer script, and then you simply plot the water track, the current, and then the course and speed made good.